All right, so today our lecture is going to be on chapter 10, and we're going to be talking about classes and object-oriented programming, which again, you are familiar with this aspect of programming already. So this is just going to be a little recap, and you're going to learn how to do it in Python too, because it has some differences with Java. All right, so let's begin our lesson by just remembering that there are two different ways to program. There are the general ones. There are only two ways to program. The first one is procedural programming, and that is an old way of writing programs. Whenever the people who used to code, they would write functions that would perform some sort of tasks for them. So far, everything that we've done in Python is procedural programming. We just used function or methods to perform some sort of actions for us. So we have not been using object-oriented programming. However, the chapter 10 exercises are going to be on the object-oriented programming. All right, so object-oriented programming, it's in the name basically. So we focus on creating objects and then doing something with those objects. So instead of just doing performing a lot of calculations or writing a lot of functions, when we do procedural programming with object-oriented programming, we are creating some sort of object, and then we want to perform some sort of manipulations with that object. And just that object. So that object is basically an entity that's going to contain data fields, which are your variables. It's going to contain data fields, and it's going to contain procedures, which are your methods. So you're going to have an object that will have some sort of variables that are attached to that object, as well as methods that you can use to perform manipulations with those variables. Let's see. So this is just a little example. So the data attributes, those imagine them as just variables. And then the little circles, imagine them as methods that's going to perform, do something with those variables. Now, another couple of terms just to remember is data hiding. So data hiding is a way to hide basically your data from your object's data from anybody who's outside of that object. So this is just a way to hide your object's variables, and you achieve that by making your variables private, and that way nobody outside of your object can access those variables or change those variables if they don't have to. Object reusability, again, nothing too complicated. This is just a term to specify that you can reuse your objects in other different programs. You can, if you have created one object that performs some sort of task for you, then you can reuse that object later in your other programs. Let's see, data attributes. So data attributes, as I said before, just think of them as variables. So if we have a clock object in this example, the data attributes would be second, minute, and hour. So these are just the variables that's going to describe what your object has, what characteristic that object has. For example, with the house, the characteristics would be such as how many stories the house have, how many bedrooms the house has, and up to the color of the wallpaper. So the data attributes are up to you when you're designing your object, and there can be as many or as little data attributes as you want them to be. Now, there are two different methods that you can use within your object. These are either public methods or private methods. And public methods are those methods that will help any external code. So anybody who's outside of that object, the public methods will help those instances communicate with your object and with your data attributes of that object. So public methods allow anybody who's outside of your object to work with the variables of your object. Now, the private methods are strictly for using them within the object scope. So nobody outside of that object can access the private methods that exist within that object. Now, classes, again, this is just a recap. You are familiar with this already. Class is just think of it as a blueprint for your object. Think of it, it's that simple, nothing too complicated, just a blueprint for your object. So you can create a class, and then you can create many other different objects from that class. And an instance of a class, that is what we call an object. So whenever you create an instance of a class and you hear that term, just think of it as somebody creating an object from that said class. Let's see. Yeah, so this is an example. As I said, think of it as just a blueprint. So we have a blueprint that's going to describe a house, and think of it, this is right here. This is going to be a class, this one. And then these are our objects. So house 1, house 2, house 3. And these can be different. So for example, if we have a blueprint just for the house plan, so where the living room and the bedrooms are located, we can specify which color do we want the roof to be. For example, this roof can be red. This roof can be yellow, and this object's roof can be green. So your objects, they do not have to follow the blueprint of the house to a T. So if your blueprint does not specify which color of the roof your house needs to have, then it's up to you as a programmer to decide which one you want to use. So classes are very good for just a general idea of what the object should have. However, all of the customization is up to you whenever you create that object. Now let's look. Class definition. Class definition is just whenever you are writing your class, this is the way you have to define it. And the format in Python is like this. So you're going to put class, and then you're going to put your class name, whatever that name you want to be, with a colon. And then everything else after this colon right here is going to be indented and going to belong to your class. The class names will start with an uppercase letter, just to differentiate the class from anything else. So they will start with a capital letter. And there's also such thing as self-parameter that do not exist in other languages. So self-parameter is strictly Python. And what that means is basically whenever you're working with any type of data and you're sending that data into a method of your object, you have to specify the self parameter just so you know where those attributes will go to. So just so you know where those arguments are going to whenever you're working with them inside of your object. And I know it's a little bit confusing. I'm going to show you an example of it in a little bit. Initializer method, that's the way the constructor is called in Python. So it's nothing too, again, it's not new for you. Only the name is new, the initializer method. However, just think of those constructors that we covered in the Java class. Whenever we create our object, we have a constructor that comes in and initializes the values of the variables that your object has. So that's basically the same thing, initializer method. It's just whenever you create your object, your variables that object has will be initialized whenever this method is called. This is the way it looks like. So for example, we have our class coin, and then we have, this is our constructor or initializer method, whatever you want to call it. And you see that we're sending this self, we have this parameter called self. So this is just whenever you're going to be creating your objects, instead of self, you're going to be sending the object's name. So since this is the class, you will be creating some amount of objects from this class. And in this constructor, you will send the object that needs to be created. Now, what this initializer method does, it just assigns the setup, which setup is, I would think it's a variable that exists somewhere inside of your object or gonna exist. It assigns setup to heads. So we're just creating a class that's gonna do either heads or toes for us. Okay. Now the definition toss is going to be a method that's going to either assign heads or tails to your variable side up. So heads or tails. And then the definition get side up is our getter. Again, you're familiar with those setters and getters. This is just a getter that's going to return the variable side up back to whatever this method is called. To create a new instance of a class, so this is the format to create your object in Python. So you're going to assign some sort of variable name, obviously, to your class. Then you're going to assign it to the class name. And then whenever you want to create an object, just name your object something that represents whatever that object is supposed to be doing or whatever that project is. So this example, my coin equals coin. And here's our coin class. So we have just created a object called my coin from the class coin. So nothing too complicated. There's nothing like in Java when you have to write multiple lines of code. So it's fairly simple. You just put a name of the object that you want it to have, equal sign, and from whatever class you want to derive that object. Now, let's see, class definitions. Again, to use any methods, it's the same as in Java. To use any methods on your object, you have to put dot and then the name of that method. So it uses the dot notation. Again, just to recap, nothing too new for us. So in this case, we have created an object called myCoin that is a part of coin class. Then whenever we want to use the toss method, remember the toss method is going to assign either heads or tails to our coin. We just put my coin dot toss with parentheses. And then another method get side up, and that was the last one that I showed you in that class. So to get that value that we just got from this method, we will use my coin dot get side up, and we're going to print that. So whatever happened whenever we executed the toss method, our coin was assigned either heads or tails. And then after that, we're just retrieving that value and printing that value on our screen. All right, let's see. All right, techniques for designing your classes. So again, a recap of UML diagram. UML diagram is a standard, is a golden standard in programming. And whenever you're creating your classes, you will be using UML diagrams, which stands for Unified Modeling Language. And the general layout of a UML diagram is a box that's divided into 3 sections. Let me show you this. So your class name goes right here. On the very top line, you will put your class name. Then inside of in the middle, on the second line, you will put any variables that your object will have. And on the last line, you will put any methods that your class has. So nothing too complicated. Class name, variables, methods. Let's see. Now, whenever you're developing your objects and whenever you're creating your classes, you have to identify a couple of things before you even begin. So the first one, you have to write a description of the problem domain. And what that means, you just have to write what your problem is, how you're supposed to fix it, any ideas that you have about fixing that problem. So just write it down on a piece of paper. Then the second one, you have to identify all nouns that exist inside of that description. Now, when you look at those, there's going to be a lot of them, a lot of nouns that you put down in your description, probably. However, get rid of the duplicate words, get rid of words that do not belong to your problem. And then after that, the nouns that you are going to be left with, those are potential classes that you might have to program in your program. However, then after that, you have to look at them and obviously use your own logical thinking and see which classes you actually have to create and which classes you don't have to create. Now, let's see. Let's look into each one of those steps a little bit more. So the written description of the problem domain, you can either do it yourself or somebody else will do it for you, or maybe there's an even whenever you go and work somewhere else, maybe there's a whole group of people that's going to be working just on writing those descriptions of the problem domain for you. What should be included in those domains are physical objects that are simulated by the program, then the role played by a person, if there is one, of course, then the result of some sort of event that happened, and record keeping items. So after you have all of those things listed, after that, you have to identify all of the nouns that exist in what you wrote down. You can just underline them. It doesn't really matter. Just identifying all of the nouns. If those nouns appear twice, just cross one of them out. And after that, all of those nouns that are in front of you, they might be relevant to your problem. Now, if they are relevant to your problem, then you will have to write a class based on those nouns. And obviously think what those nouns need to have whenever they turn into classes, and so on and so on. All right, what a class should be doing. I mean, again, another recap what the class responsibilities are. So class is responsible for knowing, and what that means, it needs to know how many variables it needs to have, how many method it needs to have, and what it should be doing. And again, the actions the class is responsible for doing. So the class needs to know what exactly the methods it needs to have, what exactly those method needs to be doing, and so on. Let's see, find out the class responsible look. Yeah, so basically why we would use object-oriented programming, just to save our time and just to help us as programmers reuse the code that we are already working with. And there's a lot of other benefits, such as data hiding, data encapsulations that we covered in the very beginning of this lecture. But I think that is it for today. Yeah, that is it for today. So if you guys have